Welcome to the fourth video of this tutorial. Now we will see how random forest regression model can perform on our existing dataset. And to import the details of the random forest regressor, we use the sklearn library, and then we define the model with the maximum depth of 10, which means that it will split 10 times the dataset to find out the best match to predict the value that we want. So again we split it by 80% and 20% for training and testing. We use the same line, of course, like we did earlier, and then we assess the performance of the model. We see that it is more than 91%, the R-square value, and the accuracy is 3.48. so it's higher than the support vector machine that we have found. And the weather file we used, that is the less number of weather features. See, if we improve the number of weather features, we see that it's kind of similar, like 91.6, it goes to 91.7, so there's not much improvement. And if we want to see the graphical representation of the predicted value over the original data, then we plot the data. But here, as we did not define the size of the figure, so it came as a default figure size, which is much smaller. And then but we can still improve the figure size by defining it. So we see that it is again around 91% of the data can be predicted by the model with an accuracy of around 3.5. And this is the prediction. So we see based on the training data, it is 91.7, but on the testing data set, it is 88.38, the R-square value, and also the error increase is higher. So that means it is slightly overfitting, but it is negligible in a way that is only the difference is not much. So let's see what happens if we want to find out a better parameter. So again we use the grid search, and as a random forest, it actually not take much time like it used to take for support vector machine. So it's very quick. You can check it yourself that we first define the parameters, and then we define the grid and the model, which model we want to check these parameters for how many times, and what are the different combinations we want, how many, like the cross validation. And then we train it, and we bring the maximum depth, that is the best is 12. So let's check what we find with the maximum depth 12, and we just copied the same lines of code, and we see the performance is 94 for the training dataset and 89 for testing. Although it improved by 3, but this only improved by 1. So is the improvement is not similar for both the training and testing. And again we can check further, like maximum depth up to 30, and we see 30 is the best. Then we can check with the maximum depth of 30 what is the performance. We see 98% for the training dataset, and for the testing it is 90%. So again it improved quite some big amount, but not the same amount for the testing dataset. So we can conclude that not to increase the complexity of the model, we can consider maximum depth around 10 that we have found earlier, where we see the similar performance for both the training and testing dataset. So that's it for till now to develop the model. So let's go how we can actually allocate the budget for the building using the predictive modeling. So for this, let's import the cost file that we have for a month of January. What is the cost in of the energy? So we import the Excel file that is again from the Google Drive, and we just copied the path, and this is how the cost file looks like. That from the 1st of January until the 31st of January, this is the hourly cost we have. And then we set this time column as an index. So then we check if there is any missing data. We see it is already clear. So like we have the weather file only without the relative humidity. So let's consider this, and we update the weather cost data file, and then we define a new variable for the scaled data of the cost file, and then we can predict the consumption based on the model that we have identified earlier. And we see how the predicted data file looks like. It's just an array of 744 values, because we have these rows and we are predicting the energy. So if we convert it into a data frame with a time series, then actually we can perform further analysis. So let's convert it into a data frame with the help of pandas library. Here with the data frame function, this predicted becomes a data frame, and we define the name of the column as kilowatt hour, and this is how it looks like. So it was an array and now it is a data frame with a serial number. So let's bring then the index of the weather file to this predicted data frame. So the index was the time, and we bring it here. So let's make this time column as an index of this predicted data. So for this we use this set index function, and it becomes an index. That means it's now a time series data frame with 744 rows and a single column. So now we plot the hourly forecast consumption in kilowatt hour. So for this we define the figure, then plot the predicted data, and then we set the labels for Y and X, and this is how we see. So what is the hourly predicted consumption? Is this is the hourly predicted consumption. This is how it looks like. That means if we see there is a weekly peak, and there is a bit of less consumption during this period, maybe because of holidays, and again it is high because of the working days, and then in the weekend there is less consumption. So the hourly forecasted, we plot the hourly forecast consumption in kilowatt hour and calculate price for the whole month. To do that, we see if the price is 23 cents per unit, then the hourly cost, we just multiply the unit with the cost of the electricity. So this is what we find the entire cost, and we then resample the hourly cost on a daily basis, and this is how the function look like, which we did earlier. The hourly cost resample with D, it stands for daily, and then we take the summation of the whole day, that means 24 hours, and this is the total day total cost for the entire month. And if we want to see how the predicted hourly consumption compares with the hourly price, it is actually the same, because it's just a different different scale, that is the euro, and this is here the kilowatt hour, but we don't see the lines, the curves. So to make it visible, we change the type, like color, and then we see with a dot line, we see both the curves. And we can also compare the hourly per liter consumption on a daily compared to the daily price. This is the daily average, daily sum, and then this is how it looks like. So at the end, we can set a visual threshold in the forecast when the model predicts higher than a budget limit. So if we want to put a budget for a daily consumption, like for example, an X is a horizontal line, we put a line at 160 unit. So if on the daily consumption, if it exceeds, then there will be a warning. So we set a label warning for over budget, and the location will be around 180, and we set the plot text, that is the location of the text, and we also define the font size, and this is the lines of the code for labels, and with the rotation, the vertical, we actually change the direction of the title, and this is how the final figure looks like, the kilowatt hour. That if we want to put an alarm that if the energy consumption is higher than expected, then the billing operator can be warned to reduce some of the unexpected consumption for the building. So thank you for following the complete course. I hope you enjoyed the tutorial and it will be helpful for your ongoing projects, and we will see in our next tutorial that will be more relevant to your existing job. Thank you and have a nice day. Bye.